Hey guys, welcome to week 6. I'm just going to go over your assignments for the week. I hope that you all had a great weekend. So, we miss you very much. This week we will be completing the following. Watch the video from slide 2, that is this video. Fill in slides 7, 8, 12, and 14. That's going to be worth 40 points, so 10 points a slide. You need to complete the Delta Math assignment, which I'll show you guys. It's about transformations. That's going to be another 40 points. And then I want you to head on to Prodigy. Complete at least 15 questions, and we'll give you 20 points. You already have your accounts linked, so if you need your username or password, just let us know. You also have to complete Dreambox, just like every other week, for at least 40 minutes, and at least 20 of those minutes need to be on an assigned focus lesson, which is this icon. You have to come to our Zoom meeting Thursday at 1:30. Remember, it counts as a grade, and drop some memes on slide 17 to tell us how you're feeling this week. As you can see, these are all links that you can click on, and I will be going over what you're supposed to do on each slide specifically. This is where I'm going to put this video that I'm making right now. All right, so just as a reminder, congruent means same shape, same size. So here are two, I have two rhombuses, rhombi, and they're 2 by 2, which means that they are the same shape and same size. If I were to move this one and put it on top of that one, it would fit perfectly. Similar shapes are the same shape, but they're different sizes. They're scaled side lengths. So notice that this little rhombus is 1 by 0.5 inches, and this bigger one is 3 by 1.5. If I multiplied this side length, this base, by 3, I would get 3 inches. And if I multiplied this height by 3, I would get 1.5 inches. So notice how I multiplied. It's scaled by 3. The scale factor is 3 because I can multiply both sides of this by 3, and I will get this. All right, so that's just a reminder. Just keep it in mind. Translations. Look at this goat. Notice that he's sliding. Get it? Translations, sliding. Anyway. All right, so here's your first slide. Remember, always write your ordered pairs as X, Y. Always have them in parentheses with a comma in between. So let's look over here. I have my pre-image, triangle ABC, triangle ABC, and I wrote my coordinates for triangle ABC. And down here I have my image. Remember, pre-image is the start, and then image is what you get. Notice how I have A prime, B prime, C prime, and I labeled my triangle A prime, B prime, C prime, and I wrote my ordered pairs. My rule for this is, in words, triangle ABC, so this guy, ABC, moved to the right or along the x-axis 11 units and down 10 units. So if I took point A and went over 11 and then down 10, I would end up at A prime. If I took B, I would move over 11 and down 10, and I would be at B prime. And C, same thing, over 11, down 10, C prime. So algebraically, what I'm doing is adding 11 to my x value because I'm moving to the right 11. So whatever my x value was, for example, A was -7 was my x value. If I add 11 to that, I'm going to then be at 4 on my x-axis. For my y, I'm going to subtract 10 because I'm going down 10. All right, so algebraically, I'm writing this as x plus 11, y minus 10. That means if I only had my pre-image points and this algebraic rule right here, I could add 11 to each of my x values, and I could automatically know what my image would be, because then I could subtract 10 from my y values as well. Notice that -7 plus 11 is 4. -1 plus 11 is 10. -7 plus 11 is 4. 9 minus 10 is -1. 1 minus 10 is -9. 1 minus 10 is -9. So you're doing something to all your x values and something to all your y values to come out with your image. All right, let's look at the next slide. Here's another example. Same thing, pre-image. I have my 3 points here, A, B, C, A, B, C. My image, A prime, B prime, C prime, A prime, B prime, C prime. my rule. Notice how I'm starting with this one because this is my pre-image. My primes represent my image. That's what happens after the transformation. So my rule in words, triangle ABC, this triangle here, moved to the left. I always like talking about my x-axis first. So I moved to the left 6 units. Let's see, let's move A to the left 6 units. 1, 2, 3, 4, 5, 6. And up on the y-axis 11 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. If I do that to each one of my points, if I move 6 to the left and 11 up, I'm going to end up at the prime of whatever this was. So algebraically, I'm subtracting 6 from my x value, so x minus 6, because I'm moving left 6. And I'm adding 11, y plus 11. I'm adding 11 to my y value. Subtracting 6 from my x values, adding 11 to my y values, and that will give me my image coordinates. All right. So this slide is the one that you'll be doing. So I gave you the 2 triangles. You're going to first look at the pre-image. Remember, that's what you start with. ABC, triangle ABC. I want you to write the points here. Then you're going to look at A prime, B prime, C prime. You're going to write the points there. Now check what happened. What happened to this triangle? See, did it move left? Did it move right? Did it move up? Did it move down? Write it in words. And then write it algebraically. What happened to my x values? Did I add to it? Did I subtract to it? What about my y values? Figure it out. All right. Use the other 2 slides as your resource. Here's another one, but this time I gave you the pre-image coordinates and I gave you the rule in words. So here is my pre-image. Triangle ABC moved to the left along the x-axis 8 units and up on the y-axis 2 units. So what you need to do is take this triangle, click and drag it to where it's supposed to go, and then there are labels underneath, A prime, B prime, C prime. Make sure that you're labeling it correctly. You can just click and drag these pieces, and you're going to fill in these coordinates here for the image, and you're going to write the algebraic way of this rule. All right. If you've watched up to this point, I want you to leave a private comment on your assignment with your middle name. All right. When you think of translations, just remember
right foot up, left foot slide, left foot up, right foot slide. Basically, I'm saying
so I don't think that you guys can hear my computer, I just realized, but you will be able to see it when you do your own. And I'm sure you guys know what this song is. All right, reflections. All right, so once again, remember always X, Y. I'm going to talk about my pre-image here, triangle ABC, and my image, A prime, B prime, C prime. A prime, B prime, C prime. All right, so the one thing I want you to notice is point B is 1 unit from the y-axis, and so is point B prime. Look here, I'm 1 unit away from the y-axis, 1 unit away from the y-axis. If you notice, every point is like that. I can see right here that A is 7 units away from the y-axis. A prime is also 7 units away from the y-axis. C is 7 points away from the y-axis. C prime is also 7 units away from the y-axis. So I wrote my coordinates and my rule in words. Triangle ABC, that's this first one over here, was reflected over the y-axis. It flipped over the y-axis. My x values became the opposite and my y values stayed the same. Let's see what I mean by that. My x values became the opposite. So right here, my x values are -7, -1, and -7. Over here, it's 7, 1, 7. So it's the opposite of whatever it was there. So my x values became the opposite and my y values stayed the same. 9, 1, 1. Oh, that's ironic. 9, 1, 1. All right. So they stayed at the same spot up here. A stayed at 9 on my y-axis. B and C stayed at 1 on my y-axis. But my x-axis, my x value, became the opposite of whatever it was. So before it was, over here it was -7, now it's at 7. And over here, -1, now we're at 1. And here, -7 at 7. All right? So algebraically, it's saying -x y, because it's the negative version of whatever x was, and y stayed the same. Let's look at another one. Oh, this is the one that you guys are going to do on your own. So I gave you guys the pre-image and the image, and I plotted them for you. Now you guys are going to write the words. What was it reflected over, the x-axis or the y-axis? And algebraically, what's it look like? What happened to the x value? What happened to the y value? All right. Here's another one. Again, remember always xy. Here's your pre-image. Here's your image. Pre-image, ABC. Image, A prime, B prime, C prime. Notice points A and A prime are 7 units from the x-axis. So A and A prime. So I'm 7 units away, 7 units away. B and B prime, each 1 unit away from the x-axis. I might have said Y before, sorry, x-axis. And C prime, same thing. So when it's reflected, it always has to be the same distance from whichever axis or whichever point of reflection that you reflected it over. So in words, my rule, triangle ABC was reflected over the x-axis because it flipped over that x-axis. My x values stayed the same and my y values became the opposite. So that's x negative y is how I would write the rule algebraically, because my x value stayed the same and my y value became the opposite. All right, if I were to fold this coordinate plane right in half, right along this x-axis, these two triangles would lay right on top of each other, which is exactly what we want. If we go back to this one, if we were to fold right along the y-axis, these would lay right on top of each other, which is exactly what we want. All right, so this is the one you're going to try on your own. You're going to fill in the ordered pairs, and you're going to write the rule for me. With reflections, just remember each point from the pre-image needs to be the same distance from the line of reflection, which is usually an axis, as its corresponding point on the image. So basically A and A prime are each the same number of units from the line, B and B prime are each the same number of units from the line, etc., just like I just showed you guys. A pre-image and its reflected image are congruent, which means that they're the same shape and size. Those triangles did not change the shape or the size. If you fold the coordinate plane along the line of reflection, which is whatever axis you reflected over, the pre-image and image should lay directly on top of each other, which is what we just talked about. All right, so this is what I was talking about. We want you guys to let us know how you're feeling this week. This is how Mrs. Schomburg and I are feeling this week. We miss you guys, but we're also thankful for you guys. We're really proud of you. We're a little overwhelmed, and we kind of miss school. I want you guys to put on this page some memes of how you're feeling, because we want to know how you're doing. All right. So just to recap, make sure that you are filling out the slides that need to be filled out. So that's slides 7, 8, 12, and 14. You need to complete the Delta Math assignment. Actually, let me show you the Delta Math assignment real quick. It's transformations. It's 4 parts, but you only need 5 correct on each. So I made it a little quicker this time. All right. So you need to fill out the 4 slides. Make sure you watch this entire video. Do the Delta Math assignment, 15 or more questions on Prodigy and Dreambox, and make sure you come to the Zoom meeting. And then please drop some memes. Let us know how you're feeling. All right. If you happen to finish this video and you're at the very end right now, please also leave another comment for us under your name for this assignment saying that you miss math a lot. All right. We want to know who's watching these entire things. All right. Sorry, this one was a little long. It's a lot to go over without seeing you in person. But I hope that it helped giving you examples and whatnot. Please let us know if you need anything at all. We are here for you guys. All right. We miss you. We love you. And we will talk soon. See you Thursday. Bye.